2.3 is some laws about limits. Okay, that can simplify our calculation. So the rules are basically if you have operations, you have addition, subtraction, product, quotient, you can just take the limit of each component, right? That's the basic idea for the limit laws. But for quotient, you have to be careful because the quotient cannot be zero, and for all other operations, there's no limit at all. All right. For example, if you have a limit, right, x goes to say 1. Now, if I say x goes to 1, that means it should be true for x goes to 1 minus and 1 plus. Okay, so let's see, x cubed minus 2x plus 7. All right, you want to know the limit of that thing, that term, when x is getting closer and closer to 1. So you can just do the limit of each component. All right, minus 2 times limit of x plus 7. Right, the limit of 7 is always 7, so we don't need to write down the limit. Right, so we do the limit for each component, and then we just, no, that one is 1, right? That one is also 1, so you just take 1 cubed minus 2 times 1 plus 7. That's 1 minus 2 plus 7. That's equal to 6. Right, this is how we use limit laws to get the limit of some complicated term. Okay, just do the limit of each part, each component, and then combine them. So this is an easy example. Sometimes you have to manipulate the term using some tricks, right? And then you can get the answer. So for example, if t goes to 0, or we can say x goes to 0, when x becomes closer and closer to 0, what happened to that thing? All right? So, first you look at the denominator and the numerator, right? The denominator is x squared. So if x goes to 0, it's just 0. So you have a 0 on the denominator, then that can give us trouble. So if you have something like that, first thing you can do is you can try to simplify this term. Right? You don't want to put 0 on the denominator. So how do you do that? Now the trick is, if you see something like square root minus a certain value, you want to multiply by this square root plus that value. So this is what you can try. Right, you still have x squared, but let's multiply by x squared plus 4 plus 2. And then we multiply by the same thing on the bottom. Right, so this is just 1. So basically you just multiply by 1. That wouldn't change anything. But if you do that, the numerator will become x squared plus 4 minus 2 squared. Right? Or you can, if you want, you can square that, minus 2 squared. Right? We use a minus b times a plus b is equal to a squared plus b squared. Right? We use that identity. Now on the bottom you have x squared and x squared plus 4 plus 2. The reason we want to do that is, if you look at the this original term here, right, this limit, if x goes to 0, the bottom will go to 0, right? If x goes to 0, the square root x squared plus 4 will be close to square root of 4 because x is close to 0. So you basically have something close to 2 minus 2. So the numerator will also be 0. So we have 0 both on the top and also on the bottom. You get trouble because you don't know how you get the 0. So you want to get rid of the 0 on the denominator. All right? And if you multiply by this thing, both on the top and on the bottom, you can see that you get rid of the 0 on the bottom. Because on the top you have x squared plus 4 minus 4. On the bottom you have x squared. Like that. Okay? And these two cancel, and you have x squared cancel. So what you get is a limit 1 over square root x squared plus 4 plus 2. Now you have a plus sign in the middle, right? This is a plus. So you don't have this 2 minus 2 thing, which gives you 0. Here you have 2 plus 2, right? If x goes to 0, right, this is like 0. And you have 4 plus 0, that's just 4, and the square root, that's 2. So we get 2 plus 2 on the bottom, and that will give you 1/4. Okay, so the limit is 1/4. And this is how you do that. All right, so that's one example. Another case we see quite often is if you have a quotient of two polynomials, as in this example. Like that. All right, so t, we use t here. You can use any symbol you want. T, x, doesn't matter. So here, t will go to 4. So the bottom will be like 0. And if t is close to 4, you can see that the numerator is also close to 0, right? Because you get 4 squared, that's 16, minus 2 times 4, that's 8. 16 minus 8, that's like 0. So if you have polynomials, what you can do is you try to do the factors, to find out the factors. So for the numerator, you have this. You can factorize the term to be a product of two things. Okay? So this is simply t squared minus 2t minus 8. All right? Now, you have t minus 4 both on the top and also on the bottom. You can cancel these two. Remember that we can do this because t approaches 4. That means t is a number that is close to 4, but t will never be 4. So you can cancel t minus 4 because that's not 0. So what you get is simply a limit of t plus 2. And if t is close to 4, that's 6. Okay? So that's something you see all the time about the limit. Now, one last thing in section 2.3 is the squeeze theorem. That means you have two things. What you really want is squeezed in between. Okay? And so you have, something like that. You have your function goes like this. This is your fx, right? And you want to know the limit of the function at, say, a. Okay. Now, what you know is you have two other functions. One is the blue one, which is always, higher or bigger than your fx. And the other one is the red one, which is always lower, smaller. Okay? So I can call that gx, oops, let me use a blue one. So that is gx, and the red one I call that function hx, right? So your function here, which is fx, is sandwiched by gx and hx, right? It's always in between. And if the limit of the two envelope functions, right? If this is equal to the limit of hx, if they're both equal to L, right? If someone higher than you goes to L, if something below you goes to L, then you must go to L. So if that's the case, we have the limit of fx is equal to L.